Dear students, welcome to this session of designing of push-down automata. In previous sessions, we have discussed certain problems, and on the basis of those problems, I had given you some problems for solving at home. Among those problems, the first one was L is equal to A to the power n, B to the power m, C to the power n, where n and m is greater than equal to 1. So again, we for solving or for writing the push down automata corresponding to any language, we have to first check out the strategy. Here, if we look at number of A's and number of C's are equal and number of B's are independent of it. So as we have to match number of A's with the number of C's, so our strategy will be we will push all the A's over the push down store. Then when we will be receiving B's, we will maintain the status of the stack and consume all the B's. Then when we start receiving the C's, corresponding to each C, we will match it with one A. So if the number of A's and number of C's are equal, then we will be popping out all the A's from the PDS, and our PDS will again be containing only the initial push down store symbol Z0. If that situation comes at the end of the string, then we will signal the success by emptying the push down store. So this will be our strategy, and I have already written the transitions corresponding to it. So one by one I will be discussing these transitions. So our first transition is as per the initial situation. Initially we will be in the start state Q0. At the top of the push down store there will be Z0, and we will be receiving our first symbol that will be an A. Okay. So Q0 A Z0, we have to push this A, so that's why we have not changed the state, and here we have changed the status of the stack by pushing this A over the push down store by writing AZ0. So this particular transition will push the first A over the push down store. Then now we are having A on the top of the push down store. So if we get further A, so situation will be Q0 A. So A we are receiving from the input, and A is also present on the top of the push down store. So this A in the input also has to be pushed. So that's why we have written here AA. So we will not change the state because same operation we are performing, and we will push this A also on the push down store. So by using this second transition multiple number of times, we will push all the A's. So up till now, by repeated use of this second transition, we will push all the A's over the push down store. Then we will start receiving B's. So still we are in the state Q0. We are receiving the first B, and at the top of the push down store will be an A. We have to maintain the status of the stack because we don't have to match these B's with the A's. So these B's we will have to simply consume. So that's why we will change to the state Q1, and we will maintain the status of stack by writing this A over the push down store. We have changed the state because we have changed the operation. Up till now, we were pushing the A's from the input to the push down store. Now, after receiving the first B, we are changing to the operation of maintaining the stack. Now we are not pushing. So that's why as operation has changed, so we have changed the state from Q0 to Q1. And we have maintained the status of the stack. Now we are in the state Q1 and receiving further B's. So this B will be receiving, and on the top of the push down store will be A. So we will maintain the status of the stack, and we will remain in the state Q1 until we are receiving B's. So in this manner, we will be consuming all the B's in our input. So up till this point of time, we are in the Q1 state, and we have pushed all the A's and we have consumed all the B's. When we have consumed all the B's, we will start receiving C's. Then we are in the state Q1. In the input, we are getting C, and on the top of push down store, there is an A. Now, corresponding to this C, we have to match these C's with the A's because we want number of A's and number of C's to be equal. Okay, so because we have to match, and for matching, what we do, we perform a pop operation corresponding to each C. We will be popping one A from the push down store. So that's why we will change the state number one because operation has changed. Up till now, we were maintaining the status of the stack. Now we are popping from the push down store. So because operation has changed, so we have changed from state Q1 to state Q2. And as we have to pop, So we will be writing null. So when we write null, so topmost symbol A will be erased. So corresponding to first C, our topmost A from the pushdown store will be erased. Now we are in the state Q2. Again, we are receiving further C's, and on the top of pushdown store, if there is an A, we will remove this A and will remain in the state Q2. So by repeated use of this production multiple number of times, we will be matching all C's with the A's. And if the number of C's and number of A's are equal, then we will be reaching to a situation that input string has finished, so all C's has been consumed, and from the pushdown store, we have also popped all the A's. Then on the top of the pushdown store, we will be having Z0. So we are in the Q2 state. On the top of pushdown store stack, we are having Z0, and input string has been exhausted. So we are taking a null move. We are taking null from there, and we will not change the state, and we will simply erase this Z0 to signal the success, because number of A's and number of C's we have matched, these are equal, and all the intermediate B's we have successfully consumed. So this is the solution for this particular problem. Now we come to the second variant of the problem, where we have defined that n is greater than equal to 1 and m is greater than equal to 0. So if this condition m greater than equal to 0 can be broken into two conditions, when m equal to 0 and m greater than equal to 1. So if we take this condition m greater than equal to 1 and n greater than equal to 1, so corresponding to this, we have already written a solution. Now we take the additional condition, that is m equal to 0. So what will be the effect of this condition, m equal to 0? So when m equal to 0, meaning thereby there is no B present, only A and C are present in our string. So our string will be of the form A to the power n, C to the power n. So simply we have to match the number of A's and number of C's. So our strategy for such kind of strings will be, we have to push all the A's and then we have to match all the C's corresponding to the A's. So pushing we can perform using this only. So from the starting we will be pushing, up till this point we will be pushing all the A's. So up till now we have pushed all the A's, so we are in the state Q0. Now we will not be receiving B's because m is equal to 0. We will directly receive C's. So means when the state is Q0 and on the top of the pushdown stack is A, we will be receiving C's directly. So it will be the condition corresponding to delta Q0 C A. So Q0 will be the state, on the top of pushdown store there will be an A and we will be receiving C's. Now what we have to do for these C's? So whenever C comes, we have to match C's corresponding to the A's. Means corresponding to each C we have to pop one A. Okay. So we will pop. So certainly we have to change the state. So we will discuss what state will be going, but we will be writing null here because we have to pop this topmost symbol A. Now question is where we should go. So when in our n greater than equal to 1, m greater than equal to 1, we have found C in the state Q1, and on finding the first C we have changed to the state Q2, and rest all other C's we have matched in the state Q2 only. Okay, so now we are receiving our first C in the state Q0. So we will change to the state Q2, the same state, okay, so in which we were matching all other C's. So now we'll move to the state Q2, and then in the state Q2 again we will get the situation Q2A and we are receiving a C. So we'll remove the corresponding A from the push down store, and in this manner we will keep on matching the C's with the A's. And when all the C's are matched with all the A's and they are equal in the number, then we will again reach to the situation that Q2 null Z0, and we will remove Z0 in that situation and we will signal the success. So only this transition we have to add for this particular situation. So when we have to convert our solution, when m is greater than equal to 0, so we will write all the transitions which are corresponding to n greater than n comma m greater than equal to 1, and we will add this additional transition for representing when m is also equal to 0. Now we come to its second variation where n is greater than equal to 0 and m is greater than equal to 1. Again, like the previous case, we will convert this n greater than equal to 0 into the two conditions. Number one, when n equal to 0 or when n is non-zero, that is n is greater than equal to 1. So when we take this situation n greater than equal to 1 and m greater than equal to 1, we have already written the solution for it. Okay, so we will consider all the transitions corresponding to these. And then additionally, we will add certain more transitions corresponding to the situation when n is equal to 0. So when n is equal to 0, it simply means that there is no A present and there is no C present in our string. Our string will be containing only the B's. So all such strings should also be accepted. So if such strings are coming to us, then in the initial situation, we are not receiving A's, we are directly receiving B's. Okay, so I am writing the transitions corresponding to the situation, that is delta Q0, B, Z0. This situation we will be getting. So we have to take an action corresponding to it. What action we have to take for B's? We have to simply maintain the status and consume these B's. So now I will be changing a state. Suppose I say Q3 and maintain the status of the stack Z0. Why I have changed the state here? I have changed state here because I am not changing the status of the stack. Either of these two things I should change if some new operation is being performed. Okay. So because I am not changed the status of the stack, so that's why I have changed the state Q3. Now in the state Q3, I will be receiving further B's. So situation will be Q3B Z0. Again, for this also I have to take the same action. I have to maintain the status of the state. So Q3 and Z0 I will be writing here. So I am maintaining the status of the state, but this time I have not changed the state because I am performing the same operation which I have performed previously. Okay. So when I will be consuming all the B's in such a manner in the state Q3, then my string is exhausted. Then I will be in the state Q3. I will be in the state Q3 and my input is exhausted, so I can take only null from there and Z0. So when I reach to such a situation, I should signal the success. So Q3 and null I will be writing means I will remove the topmost symbol, that is the Z0. So my stack will become empty, my PDS will become empty and my string will be successful. So these three transitions I have to add corresponding to the situation when n is equal to 0. Now here one thing to be noted, I have changed the state to the state Q3. If you carefully observe here, you can also change this state to the state Q1. Because here when in Q0 state you have got an B, then on the top of the stack was A. Okay, so you have changed to the state Q1 and A. So rest all other B's you were consuming in the state Q1. So that also you can do here. Rather than changing to the state Q3 in the first transition, you can also change to the state Q1 there. So if Q1 is there, then simply you will write here delta Q1 BZ0, then Q1 Z0. Okay, so rather than using the state Q3, you can use Q1 also. It is possible because if you are also receiving B here, but then your topmost pushdown stored symbol is different. Here your topmost pushdown stored symbol is Z0, while in these situations there will be the topmost pushdown stored symbol A. So there will be no confusion in between them. So you can also use the state Q1 here rather than state Q3. But wherever, if you are not sure, whenever you are using or reusing the state, you may simply create a new state. It is always safer. So these three transitions will be added for this particular situation when n is equal to 0. Now come on the third variation of this, when n and m both are greater than or equal to 0. So as per the previous example also, this can be break down in 4 conditions. These 4 conditions are that n is equal to 0 and m equal to 0, means both n and m are equal to 0. Second condition is n equal to 0 and m is greater than equal to 1. Third condition is n greater than equal to 1 and m equal to 0, means m is 0 and n is non-zero. And the fourth condition is both n and m are greater than equal to 1, means both n, m and are non-zero. So when both n, m and are non-zero, for this we have already written this solution. So we will consider all these transitions. Then come on the next situation, that is n is non-zero and m is 0. So n is non-zero, m is 0 means our strings will not contain b's. So in such a situation, we have added this particular transition, that is after pushing all the a's, we will directly get c in the q0 state. We will not get b's. Okay, so we will add this particular transition. Now corresponding to the situation when n is 0 and m is non-zero, so we have added these three transitions, n equal to 0 and m not equal to 0. It means that our string may contain only the b's. It may not contain a's or c's. Okay, so in such situation we have to add these three transitions. So we'll add this. The only condition that n equal to 0 and both m equal to 0, this condition is not handled up to now. So we will add the additional transitions corresponding to it. When both n and m are non-zero, both are 0, then it simply means that neither a and c are present because n is 0, nor the b is present because m is also equal to 0. So meaning thereby there is only one string which will be generated through this situation, that is the null string. So we have to add transition for including null string into the language. So that transition will be the delta q0 null z0, because our string is already null, so we cannot take anything from the string. So we have to take this null move null transition. So that will get in the initial situation when our when we are in our start state, and on the PDS there is the initial push down store symbol. So in such situation, what we have to do, because null has to be accepted, so we will simply make our PDS empty to signal the success. So this transition will be added corresponding to n equal to 0 and m equal to 0, and this will be the whole solution for when n and m both are greater than equal to 0. So in this manner we can solve all these four cases. Now we come on to our next example, in which our language is WCWR, where W belongs to A, B asterisk. Okay, so meaning thereby we are trying to write the PDA corresponding to a language of palindromes, and our terminal symbols in this language will be A, B, certainly because W is made up of these, and C is also present here. So our terminal symbols will be A, B and C. So these will be our terminal symbols, and a string will be of the form WCWR, means a word of A's and B's will be there. Then C is the separator which is separating it, and then after this C we will be getting the reverse word of whatsoever we have read before this C. So it is W and it is the reverse of W. Now how we can write a PDA corresponding to it? As per our PDA, we have the facility to push certain symbols over our push down store. Okay, so one simple strategy may be that this W we push over the PDA. This W we push over the PDA. When C comes, we will know that our W has end, so we will simply consume this C. Okay, and then we know after the C whatsoever we are reading, that should be the reverse of this word W. And if it is actually the reverse of word W, so if we match the input symbols which we are reading from this WR, those should match whatsoever we have stored over the push down stores, because our push down store is in the form of a stack. So when we push W over the push down store, so when we will be popping, its symbol will come in reverse order. So those can be directly matched with the WR present in the input. So this may be our simple strategy for making the PDA corresponding to it. So let us start writing the transitions for the PDA. We will be writing delta. Our initial state is Q0, and initial push down store symbol will be Z0. Now what will be our input? Our input is coming from W, and W may contain either A or B. So whether first symbol will be A or first symbol will be B, we don't know. So any one symbol may be there. So we are assuming, suppose A is coming at the first place. So if A comes at the first place, so situation will be Q0 A Z0. What we have to do? Because we have to push W, so every symbol of W we have to push over the push down store. So we will remain in the state Q0 and we will push this A by writing AZ0 there. So we are maintaining the status by pushing Z0, and by pushing A we are pushing the input which we are reading. Okay. Now suppose A was not the first symbol. Suppose first symbol was B. So what we have to do with this B? Certainly this B also has to be pushed, because up till when we are reading W, so all the symbols of W, whether these are A and B's, are to be pushed over the push down store. So that's why we have to write another transition, that is Q0. Suppose rather than A we are receiving B, so BZ0 is equal to Q0 BZ0. Why BZ0 this time? Because we are reading the symbol B, so this B has to be pushed over the push down store. So through these two transitions, or we will use any one of them certainly. So we will be pushing our first symbol in the W. Now we will read subsequent symbols in the W. Again, the second symbol in W will be what? Whether it will be an A or it will be an B. It may be A, it may be B. So we have to write the transitions corresponding to both. So let us write sub delta. Now we are in the state Q0. Suppose we are receiving an A in the input. On the top of push down store, what symbol will be? It may either be A or B. It depends on what previous symbol we have read. If the previous symbol read is A, then A will be on the top of the push down store. If previous symbol read is B, then B will be on the top of the push down store. Okay, so we have to assume both these situations. So suppose A is on the top of push down store. So what we have to do? Again, this input we have to push. So we will not change the state, because same operation we are performing, and we will write here AA. This A to maintain the status of the push down store, and this A to write whatsoever we are reading in the input. Okay, so we are pushing this A. Then similarly, suppose Q0, in the input we are receiving A, but on the top of the push down store, this time not A, it is B present. Suppose the previous letter which we have read was B. So this will be the situation. What we have to do? We have to push this A over the push down store. So again, we will not change the state because same operation is there, and we will write here A, B. Why A, B? This B to maintain the status of the push down store, and this A which we are reading in the input, we are pushing it over the PDA. So that's why we are writing AB here, is it? So we will maintain the status as well as we will push something extra. Then Q0, suppose now this time input symbol is B. Again on the top of push down store may be A, and similarly the another situation may be Q0, we are reading B in the input, and on the push down store there is also present B. Suppose previous letter was also which we have read, it was also B. Okay, so in this situation what we have to do? We have to push this B. Okay, so Q0 we will write BA, this A to maintain the stack, and this B which we are reading in the input, so that we are pushing over the stack. Similarly here also we will write Q0 B. So through these four transitions we will push all subsequent symbols which are present in the W. So up till now we will receive either A or B, we will keep on pushing. So meaning thereby all the symbols of W, when we are receiving it is either A or B, we are pushing over it over to the PDA. Okay. Up till when we have to do this? Up till we do not find a C. So suppose all A's and B's, suppose complete W we have pushed over the push down store, then we will be encountering with C. So delta Q0, I have not changed the state because up till now I am performing only the push operation. Okay. Then I am receiving C, and on the top of push down store there may be two symbols, either A or there may be a B. Q0 C B. Why? Because if the last symbol read before reading this C is A, then A will be on the top of the push down store, and if the last symbol read before this C is B, then B will be on the top of push down store. So in both the situations, what we have to do? We have to simply consume this C. This C is nothing but it is an indicator that our W has finished. Okay, so we have to simply consume it. So I will be writing here the state Q1, and then I will maintain the status of the stack. So whatsoever was the on the top of push down store, the same string I have written here. So I will maintain the status. So Q1, and here I will be writing B because B is on the top of the push down store. So I am simply maintaining the status of the stack. So that's why I am consuming only the C. And at this point of time, I have changed my state from Q0 to Q1 because up till now I was pushing whatsoever symbol A or B I was getting. But when I receive C, I have changed my operation. I am consuming this C. So I am not pushing. So that's why I have changed the state from Q0 to Q1 in both the cases. So whatsoever is the case, ultimately we will change into the state Q1. So coming up till now, we are in the state Q0, we are pushing. Whenever we are changing to the state Q1, it simply means that our string W has finished. Now we have to start the operation of matching. I have to start the operation of matching. Now I will be writing the transitions corresponding to the matching. Now in the matching, we will again receive in the input either A or B. And on the top of pushdown store also we will be having either A or B. So again 4 situations will be there when A is in the input and A is also on the top of pushdown store. When A is in the input but B is on the top of pushdown store. And similarly when B is in the input, A is on the top of pushdown store and B is in the input and B is on the top of pushdown store. Among these 4 possibilities, I will be writing transitions corresponding to the only 2. These are delta. I was in the state Q1. Okay. So A, and then delta Q1, B and B. I am not writing the transitions corresponding to the situation when A is here and B is here, or B is here and A is here. Okay. Why? Because suppose A is there. So meaning thereby whatsoever is on the top of pushdown store, the same symbol I am getting in the input. So it is a successful match. When successful match is there, I will be popping it up. So I will be it will be Q1 null. So I will simply pop whatsoever is on the top of the pushdown store. So it is a successful matching, and I can keep on doing this match until the same symbol I am getting in the input, which is also present on the top of pushdown store. So simply I will write here also Q1 null. Now here I have not written the transitions corresponding to AB and BA. Why? Because suppose A is here and B is here. It simply means that B is on the top of the pushdown store while in the input I am getting an A. So this is a mismatch. If mismatch is there, so meaning thereby whatsoever string I am getting in the input, that is not the palindrome of the W which I have already pushed over the pushdown store. So it will be palindrome only when I am getting the same symbol in the input which is also stored on the top of the pushdown store. That's why I'm not writing these 2 conditions, because in those conditions I have to reject my string. So if I am not writing my transitions here, so that string will automatically be rejected because I don't have any move in such a situation. So my machine will halt, and as my input string has not finished and my machine has halt, so input string will be rejected. So I am not writing. So because the nature of PDA is non-deterministic, we have to write only the necessary transitions. So this is important. Now one more thing you can observe here. Here I was consuming the C. Okay. And after consuming the C, I am doing the matching. But during this matching, I have not changed the state. Here also I am in the state Q1 and here also I am in the state Q1. Why it has been done? It was possible as per the guideline that we should change the state. So what I would have written here, suppose in this situation, Q2 null. If I would have written this, then I will be in the Q2 state. So meaning thereby the first symbol of this WR I will be matching in the state Q1, and then I will move to the state Q2. Then rest all other symbols I will be matching in the state Q2. So I have to write 2 more transitions of the form delta Q2 A is equal to again this Q2 null, and similarly delta Q2 B comma D is equal to Q2 null. Something like this. So this is also correct. This is also correct if you do as per the guidelines. But because here input is changed, in the Q1 state, and when there is a or B on the top of push down store, we are never getting an input symbol as A or B. So that's why it was possible that we use the similar state for this particular purpose, because Q1 is not being used for any other purpose. So I have only changed to the state Q1 once. Then I have not used the state Q1. So this Q1 state was empty. So I can use this Q1 state to perform the operation of matching. So that's why I have optimized my design here. I have not changed as per the guideline to the state Q2, but I have remained at the state Q1, and then this one is also correct. So with the experience, you will come to know in what situations you can utilize already present states. You need not to always use the guidelines, but whenever you use the guidelines, normally there is not the problem. I have also said you that these guidelines will help you in most of the cases in the correct design, but it is not mandatory that you always change your state when your operation is changing. In most of the cases it will work, but this you have to look additionally whether it is working correctly or not. In more than 90% cases it will work. Okay, so we have done it here. Now when I have done the complete matching, suppose W, C, W, R. This input, this side is actually the reverse of this W. Okay, so then all the symbols which I have pushed from the W on the push down store will be popped up. Okay, then on the top of the push down store, I will be having only the Z0. So I will be getting the situation that I am in the state Q1. My input string is exhausted, and at the top of the push down store is Z0. So this signals the success because my string has been exhausted, and this W has completely matched with this WR. So I will be in the state Q1 and emptying my push down store. So this will signal the success and my string will be successful. So this is all transitions here. Now in this whole discussion, we have left one situation. That one situation is when we have consumed this C. When we have consumed this C and move to the state Q1 and move to the state Q1. This we have done in the situation when on the top of push down store is either A or B. This A and B has come on the top of push down store only in the situation when W is not empty. If you carefully look at here at the definition of the language, W belongs to A, B asterisk. So meaning thereby W is a string of A's and B's, but if we for this asterisk we take the power 0, so W can be empty as well. It may not contain any of the symbol from this alphabet, that is A and B. So W may be null as well. So if W is null, so in the initial situation when Q0, Z0 is the situation, so we will directly get C here. So we have to write one transition corresponding to this situation as well. So now I am adding that transition also. That transition is delta Q0 Z0. That is the initial situation, and in this situation now we are not getting A or B. I am directly getting the C. So when I am getting C, what action I have to take? This C has to be simply consumed. And after consuming C, where we are moving? We are moving to the state Q1 so that we may further match. Okay. So that's why we will change to the state Q1 and we will maintain the status of the stack, that is Z0. So now we are in the state Q1 and at the top of the stack is Z0. Now in the Q1 state, because only C is present, so again my input string has been exhausted, so null will be there. So in Q1 state, I will not be able to take any one of these two transitions because here A and B as input are required. I will be able to take, but I will be able to take this transition Q1 null Z0 because Z0 is on the top of the push down store. I have changed to the state Q1, and through this null, I will take this null move and I will signal the success because only C is also accepted. So in this manner, I will include the only single letter C also in the language. So this is the whole solution for this particular problem. Now, on the basis of the example we have just described, I wish that you attempt one problem at home. That problem is L is WWR. The format of the words in this language will be of the form WWR, where W belongs to A, B asterisk. Means the word in this language will be the palindromes, and these palindromes will be over A and B, this alphabet A and B. Now, as like the previous example, there is no separator present. So C is not there in the language. So there is no separator present. So I wish that you try to solve this problem at your own at home. We will discuss its solution in the next lecture. Thank you all.